Hi there. My name is Miss Townsend and I love math. Welcome to Math with Townsend.
This video is for grade 11 students in Functions and Relations. It's video number 3 from the year-end summative.
A basketball is thrown on a court. The path of the basketball is modeled by this equation, where h is the height of the ball in meters and d is the horizontal distance it has traveled from the player, both in meters. And then there's some questions I have to answer, but I'm not going to pay too much attention to them until I'm really clear on what this equation means. So I see right away that it is a quadratic equation and it is a negative leading coefficient, so it looks like this. It's an upside down or negative parabola. I know that the two things that I'm comparing are the height above the ground and the distance. Ooh, you know what? Let me use my fancy technology here. Do that a little neater. You would use a ruler. Um, so I'm comparing the height above the ground to the distance that it travels from the person who threw the ball. So this is height in meters, and this is distance in meters. So what else do I know without doing any math? Well, I know this value is important. That value represents the initial height of the ball. And I know that because the initial height means the moment that the ball was thrown, it is 0 meters away from the person. And when I substitute 0 meters in, I get this entire term is 0, so it's irrelevant. And this entire term is 0, and all that's left is this constant term of 1.8. So I know that its starting height is at 1.8, and then the ball travels some distance and lands presumably on the ground. Okay, so now that I understand this question, what do I have to do? From what height was the ball thrown? Well, hey, I've already answered that. The ball was 1.8 meters above the ground when it was thrown. No math required as long as you understand that in standard form, the initial height is always the c or constant value. All right, well, that one was easy. Let's look at the next one. So the next one says, how far has the ball traveled horizontally when it lands on the floor? So how far has the ball traveled horizontally? It's asking me to find d. And when it lands on the floor, well, what's the height of the ball when it lands on the floor? It must be 0 meters. So this question is saying if h is 0, solve for d. So that's the math I have to do. And if you think about the diagram, I want to know this point here, what is the d value of this point? Because that's when it's on the ground. So we're going to let h equals 0 and solve for d. So I don't have to do any manipulation. It's already in standard form and it already equals 0. And I can just use the quadratic equation to solve for d. So d is negative b plus or minus the square root of b squared minus 4 times a times c. All of this divided by 2a. And then I go back and substitute in. So negative b plus or minus the square root of b squared minus 4 times a and c, all divided by 2a. My brain just works better when I can sort of do two important steps as two important steps instead of trying to do it all at once. So let's calculate this out. In your calculator, do this math. So 2.1 squared, subtract bracket 4 times negative 0.25 times 1.8, and square root that, and you should get this. And it is really important that you actually know how to use your calculator properly, like with brackets and where your negative sign is. You don't want to understand fully how to do a question and then mess things up because you're not really comfortable with your calculator. So I'm going to get two values here. One of them is negative 2.1 plus 2.5 divided by negative 0.5. And the other one is negative 2.1 minus 2.5 divided by negative 0.5. So if I calculate both of those out, I get here d equals negative 0.8, and here I get that d equals 9.2. So making sure that those make sense, I'm going to go back to my diagram. One of them was 9.2, and the other one was negative. So let's think about why one of them would be negative. That's because this parabola doesn't know that it's a basketball in the real world. It thinks it's a parabola, which means that it has a root over here. And that would be the negative root. What was it? My bad. Negative 0.8. So over here is this negative 0.8, and that's obviously not the answer we want because that's not the reality of the question. The one that I want is the positive root over here, which was at 9.2. So my answer is that the ball traveled 9.2 meters before it hit the ground. So 9.2 meters from the player who threw it is when it hit the ground. Okay. What does part C say? It says, for what horizontal distance is the ball higher than 4.5 meters? Okay, so I'm just going to go back to my diagram. So 4.5 meters, let's just throw it right here. So at some point, the ball gets high enough to be 4.5 meters, and then it goes up, reaches a maximum, comes back down, and it'll be at 4.5 meters again. So if I can figure out what values of D exist when the ball is at 4.5 meters, then I can tell you for what distance it traveled above 4.5 meters. So I hope that makes sense. So really what I'm looking for is when was the ball at 4.5 meters? And then that way I can figure out the total travel time between reaching 4.5 meters on the way up and reaching it again on the way back down. So what I need to do is I need to let h equal 4.5 and solve for d. So 4.5 equals negative 0.25 d squared plus 2.1d plus 1.8. And of course, before I solve anything quadratic, I need it equal to 0. So I'm going to subtract 4.5 from both sides of the equation. So 1.8 subtract 4.5 gives me negative 2.7. And now I have a perfect quadratic in standard form. So I'm going to use the quadratic equation. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And substituting in, so negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, and then calculate that out. So I'm not going to spend a lot of time showing you the calculations. Again, that's mostly calculator stuff. I end up with negative 2.1 plus or minus 1.3 divided by negative 0.5, and then splitting that into the two different roots, I should get d equals negative 2.1 plus 1.3 divided by negative 0.5, and d equals negative 2.1 minus 1.3 divided by negative 0.5. So calculating, here I get 1.6, and here I get 6.8. So again, what does that mean? Look at my diagram. I know that this point was 1.8 meters away from the player. Excuse me. And this point is 6.8 meters away from the player. So between these two distances is when the ball was 4.5 meters or more above the ground. So I just need to subtract them. So if I subtract 6.8 minus 1.6, I get 5.2, and therefore, let me make sure I got the wording, for a distance of 5.2 meters, the ball was more than, this is not an easy tablet to work with when I'm trying to write, but you know, you can make out my chicken scratch because you can hear my voice. For a distance of 5.2 meters, the ball was more than 4.5 meters above the ground. Okay, so I hope that was a helpful question. Lots of quadratic work, and I'll see you in the next video.